Bismillahirrahmanirrahim. My beloved students, hope by the grace of Almighty Allah, you are well. This is Muhammad Ashraful Azim, lecturer in statistics, English version day shift, Raju Gupta Model College, is going to start to deliver a lecture on Poisson distribution, which is the fifth chapter of second paper. This is the part of the syllabus of your pre-test examination. Dear students, I expect that after completing today's class, you will be able to know what is Poisson distribution, what is the definition of Poisson variate, what is the difference between binomial distribution and Poisson distribution, what is the parameter of Poisson distribution, some important properties of Poisson distribution, as well as the uses of Poisson distribution. These are the learning outcomes of today's class. Now, Poisson distribution. There is a word Poisson. From my experience, I observed that some of the students pronounce the word poison. No, it's not poison. Poison means toxin, and in that time, in the spelling, there is single S, but there is double S. SS. It's a name of mathematician as well as physicist and a statistician. His full name is Simon Dennis Poisson. He discovered the distribution. According to his name, the distribution is known as Poisson distribution. He is French mathematician and physicist. Now, Poisson distribution. You learn what is binomial distribution, and in that moment you understood that mainly there are two types of random variables. These are discrete random variable and continuous random variable. Poisson distribution is a distribution of discrete random variable like binomial distribution, but there is a difference in between Poisson distribution and binomial distribution. When the number of trial is large, then and the probability of success is very small, in that moment the distribution follows Poisson distribution. But if the number of trial is small, that means less than 30, probability of success and failure are large or approximately equal. In that moment it follows binomial distribution. So what is Poisson distribution? Poisson distribution actually nothing but the limiting form of binomial distribution. It's a limiting form of binomial distribution. So what is the limit? If the number of trial is large, that is the value of n is greater than 30, and probability of success is very small, that is merely 0, near about 0, this p tends to 0, here less than 5%, and the product of n and p is a constant. It is normally denoted by m or any other symbol. Then the limiting form of binomial distribution is called Poisson distribution. There are two key points, which are number of trial is large, that is n tends to infinity, and probability of success is very small, that is p tends to 0. So what is Poisson distribution? Poisson distribution is a limiting form of binomial distribution when the number of trial is very large and the probability of success is very small, and product of number of trial and probability of success is a constant. Now, probability function of Poisson distribution. Actually, probability function, it's a mathematical form. The Poisson distribution mathematically expressed in such a way p of x equal to e to the power minus m to the power x divided by x factorial, and the value of x contains 0 to infinity, so x equal to 0 1 to up to infinity. Here the identity of symbols, here x be the Poisson variate means variable, x be the Poisson variate, p of x be the probability function of Poisson variate of x, e be the Napier log whose value is 2.718, and m be the product of number 12 and probability of success, and it's a constant. Now, what is Poisson variate? Firstly, it's a discrete random variable. Variate means, I repeat, variate means variable. Poisson variate means Poisson variable, the variable which follow the Poisson distribution. And its characteristics is it's a discrete random variable. So, a discrete random variable when follows this function, this probability function, in that moment, that discrete random variable is known as Poisson variable. This is the probability function of Poisson distribution. Here only one variable which is x, and this variable x be the Poisson variable. Now, very most important topic is parameter. Parameter is an unknown constant. Parameter is an unknown constant. And if we know the value of parameter, if we know the numerical value of parameter, in that moment we can describe the distribution in many ways. So, the unknown constants by which any numerical value calculated from the population is called parameter. This is the probability function of Poisson distribution. Here x be the Poisson variate, e be the Napier log. There is only one unknown constant which is m, and this m be the parameter. And in Poisson distribution there is only one parameter. For sure, there is only one parameter. It's normally denoted by m. Sometimes it's denoted by other symbols like lambda or other symbols. Now, some important properties of Poisson distribution. It is repeated that the Poisson distribution is a distribution of discrete random variable. The distribution has only one parameter which is m, normally denoted by m, and m equal to np. In Poisson distribution, the mean, variance and parameter are same. That is, mean equal to variance. Which is mean? That is variance. And these are equal to the parameter. Similarly, expectation of x equal to variance of x equal to m. Another property of Poisson distribution is sum of all probabilities of Poisson variate is 1. The coefficient of skewness of Poisson distribution is 1 divided by square root m, where m is the parameter. The coefficient of kurtosis of Poisson distribution is 3 plus 1 divided by m. Normally, coefficient of kurtosis is always compared with 3. The standard deviation of Poisson distribution is square root m. You know that the standard deviation be the positive square root of variance, since parameter is m and m is equal to the variance and square root of variance m is the standard deviation. These are the overall important properties of Poisson distribution. Now, some uses of Poisson distribution. To determine the number of patients affected by coronavirus in the world, Poisson distribution is used. To find out the number of defective items in quality control statistics, Poisson distribution is used. To determine the number of deaths of coronavirus, Poisson distribution is used. The single out of four products of a meal or factory, the Poisson distribution is used. To count the number of bacteria in biology, these are the uses of Poisson distribution. There are a lot of uses of Poisson distribution. So, this is overall today's class. Learn the topic. In my next class, I will discuss the mathematical problem of Poisson distribution. Keep well. Thank you very much. Allah Hafiz.